Hello, my name is Guillermo Edwin Rosales Gill, and today I'm going to be talking about the comparison between the design that we made in Fusion 360 and the actual prototype that we built. Let's begin. So first we're going to compare and contrast the actual frame of the spin and splash. Once we do that, we're going to compare and contrast the mechanisms, which includes the motor and the solenoids. So let's begin with the comparison of the front side of the spin and splash. A few things become apparent immediately. The first one is that the actual prototype does not yet have the 5-gallon water jug. This is because we haven't yet run tests with it holding the 5-gallon water jug. You will also notice that the frame itself already has a coating that matches the same color as the one in the CAD design. This coating is not only for aesthetic purposes, but it's also to protect the actual wood from the frame itself from the water that could leak during the cleaning and rinsing and filling process. Next, you will also notice that the actual part that holds the 5-gallon water jug is not painted. This is because this is a part of the prototype and we're still going to test other versions of this to come up with a more lightweight solution to moving the 5-gallon water jug around. Next, we have the comparison between the right sides of the spin and splash. A few things become apparent here as well. The first thing you will notice is that the actual physical prototype already has cables running to it, whereas the CAD design did not. You will also notice that the prototype is missing right now the motors in this picture, as well as any of the control circuitry that goes along with it. You will also notice that the placement of the tubing systems are slightly different. We'll look at that in more detail in slides later on. Last but not least, you will also notice that the CAD system has a door handle, whereas the actual physical system is just opened manually by pulling on the door itself. Now we're going to take a look at the left side of the spin and splash. The biggest difference here is with the filling system. As you can see in the CAD image, the water comes in from the top after passing through a solenoid. However, in the actual prototype image, you can see that the tubing for the filling system is threaded through the side of the actual frame. It's attached to the frame with this small little metal bar, and then it continues to the top before going through the same solenoid and then filling the water jug with clean, drinkable water. Let's take a quick look at the top comparison between the CAD file and the actual prototype. There's not really much to say here other than that you can also see a different angle of how the filling system differs from the CAD file whenever we're talking about the actual prototype. You can also see in the back control panel that right now for the prototype we're missing all of the motors and driver boards and everything that has to do with controlling the actual prototype itself. This will be added at a later stage. The only thing that is significant about the backside comparison of the spin and splash is that, as you can see in the actual image from the prototype, you can see that it now includes the ball bearing. This is significant because it means that we were now able to attach the main axle, which is connected to the 5-gallon water jug, and thus we can spin it 180 degrees for the cleaning and filling processes respectively. Now we're going to be talking about the comparison between the mechanisms on the CAD file made on Fusion 360 and the actual prototype that we built. So the first thing to note is that it looks almost similar. You have the motor that is attached to the main axle that goes through the ball bearing and then from there is connected to the 5-gallon water jug. However, a difference that is not noticeable in this picture is that the motor that was originally intended to be used on the CAD file was the NEMA 23 stepper motor. However, we ended up actually using the NEMA 17 stepper motor just because it was slightly cheaper and still produced around the same amount of torque, or at least the torque that we believed was necessary to actually spin the 5-gallon water jug around. Up next, we're going to be discussing the lock mechanism motor. So the difference here is that we originally intended the NEMA 17 motor to be used for the lock mechanism. However, it proved to be too big. So instead, as you can see in this actual physical image, we have the Ukita motor. So the Ukita motor is smaller, but it still produces a powerful amount of torque, enough to be able to lock on to the 5-gallon water jug and hold it in place while the NEMA 17 motor spins the entire thing around. And that is the biggest difference between both of the motors that we used. Not so much how it was intended to be used, but rather what type of motor was actually used. Moving on to the comparison for the cleaning mechanism, well, you can see that there's no real big difference at all. You have two tubes that come together into two different solenoids, and then eventually, which is not apparent in the actual image, they're going to come together and go out through a single nozzle, and that nozzle is going to spray the inside of the 5-gallon water jug to clean and rinse it respectively. Now, one quick note, originally this is not how we intended to make it. After we made the CAD file, we were going to use a single, two solenoids that came attached together, and they had 2 entrances to the solenoids, and it connected it to, it was already connected the way that it was designed, this component. But it proved that the diameters for the tubings there were too small and not enough pressure could get through it. So we decided to discard those and go with our original design of using 2 separate solenoids instead. Last but not least, we have the comparison of the filling system. So we've already touched base on this before, but the biggest thing to notice is, 1, the water for the actual cleaning system is not coming from the top, but rather it's being delivered from the bottom. And 2, the solenoid is attached directly where the nozzle is going to be at, rather than being slightly removed. And essentially that's everything for the tubing system.
Well, starting with the components that make up the project. First of all, the structure. The structure is one of the most important parts of the project. Our structure is made of stained MDF. Also, we paint it with transparent paint to protect it from water. Well, the second part that make up the project is the jug support. This support holds the water jug up to fill it and down to clean it. It is made from wood, and it has a little support that can hold even better the jug into its correct side. The motors, well, we use 2 different NEMA 17 motors. One for rotate the jug support, another to rotate the holder inside the support. Well, these 2 motors are controlled with 2 A4988 motor drivers. And the last component is the solenoid bulbs. We use 3 12 volts and normally closed solenoid bulbs in order to lather and rinse and fill the jug with the help of a mixer and a chiffon to reach the needed pressure.
Our integrative project consists on 2 principal components, valves and motors, and I will focus only on the motors. We are using 2 motors. The principal motor is in charge of rotate 180 degrees the clamp that holds the jug, and the other one, the smaller, is in charge of rotate 90 degrees, and this one holds and drops the jug. We are using NEMA 16 motors, and these motors come with a step of 1.8 degrees. So this means that to complete a turn of 360 degrees, we need to deliver 200 pulses from our control. To control the motors, we are using the A4988 driver boards due to are one of the most common in the market. Actually, it costs only 34 Mexican pesos each one. Well, as you can see in the image, this driver allows us to control the direction of rotation of the motor with the pin from the bottom left, based on setting the pin to high or low. Also, we can set the distance traveled by the motor with the second pin from the bottom left, and well, this is the pin that collects the pulses. And here it is the video that shows the movement of the motors. As I said before, to complete a turn of 360 degrees, it's necessary to give 200 pulses at the motor, and as we want to complete a half turn with the bigger motor, we gave it 100 pulses that are 180 degrees, and the other motor, the smaller, is accomplishing a movement of 90 degrees, so that's mean we gave it 50 pulses. And well, as you can see, the smaller one moves 90 degrees, that are 50 pulses, sorry, and the bigger one moves 180 degrees, that are 100 pulses.
Hello teacher, my name is Reyes Mota, and I'm here again to explain the program that we did for our project. First of all, as in any project, in any Arduino project, we declare the pins that are going to be used for different components, and after that we state which type of signal those components are going to use. Let it be output or input. After that, we begin the zero signal, which is going to allow us to communicate with Bluetooth with our phone, which is going to be also explained a little bit at the end. Over here, this is where we get the start of the project, the sequence. First of all, we need to get the information from our Bluetooth device. That's where we get the chart, the C variable. It's going to be equal to the reading of the stereo signal that's going to be received with this HC05-06 model. It doesn't really matter which one you use. I'm pretty sure that for the thing that we're going to use it, either one can work out. After that, there's two options. It can either send an A or a B. An A is for the project to start the sequence, and for B it's for it to disconnect and reset the project, the machine. Over here is just basic sequence in which my peer Edwin helped me put together. It's nothing that difficult. We also separate sections to what is what for the rinse stage, the cleaning, and the filling, or whenever to turn the grabber of the jug. And that's basically all what the machine is going to do whenever we receive the signal equal to A. It ends at the filling stage. So whenever we have our jug, you know how it can start down. So whenever the sequence ends, the jug is going to be stand up the correct way, filled with water. That will be when the user is going to have to take the gun out and press disconnect. I'm still working on a little bit on the fail proof for whenever you press disconnect before the jug is taken out, because that will make some really bad problems. It could also break the machine. Trying to figure that out with the switch. Okay, so but we'll talk about in the last presentation. So whenever we have B, which is whenever we press the disconnect button on the screen, whenever we receive signal B, what the machine is going to do is going to reset itself to be ready for whenever people bring in their jug. That's basically all it's going to do. We did the same thing as in the first part. We just give it a small sequence in which it's going to do a series of steps, mostly just going to reset the motor to its original state, and just turn on and off some lids. That's all it's going to do. That's pretty much all the disconnect function is going to do, just to make sure that it's resetted, which will allow us to repeat the process. We're still working on some fail proofs, like I said before, but besides that, it's pretty much completed. Now, for the Android, I was gonna show the whole code, but it's a lot. So I'm just gonna explain it a bit with the displays that we have. Here we have, it's pretty simple. We have a list view, and a button. That button is gonna search for the Bluetooth devices that you have on your phone. Now the thing is that that list is gonna be different for each phone, because it's gonna look for any device that you've paired with before. For example, if you only have 2 devices, it will only have 2. And in case you have more than what fits your screen, you can just scroll down. That's why it's a list view. After finding the devices, you gotta choose the model that you're gonna use. Let it be HC05 or 06. After that, you're gonna get to the data process page, in which right now it only has 2 buttons. It's gonna stay like that. I think the only thing that's gonna be done to it is just make it a bit more user-friendly, kind of vague, only having 2 buttons. That's what we're using for testing. Maybe just add a little bit decor here and there. So start is the one that's in charge of sending serial signal A, while disconnect gives you signal serial B. Whenever you press a button, a toast message is gonna be displayed, which if the switch isn't doors and closed, it's gonna tell you gotta turn off you gotta close the door before starting the process. Same when removing it. If the process wasn't started, it's supposed to not be able to just disconnect without resetting. Those are the fail proofs that we're working on right now. And that's pretty much all by my part. Again, Leonardo is Mota. Hope you have a great day.